Hey guys, this video is about the midpoint formula. Before we jump right into the formula, we want to go over a few vocab words so that we understand what a midpoint is and how we would represent a midpoint using symbols. So we're going to start off with the same chart that we've been recording our vocabulary words in. You can label your notes for today midpoints or midpoint formula and your same 4 columns. So word, definition, picture, and then the last one is symbol or notation. Our two vocab words are congruent segments and midpoint. Some of you may have already learned the word congruent, and that just means two things that are the same. So in particular, if we're talking about segments, we're talking about segments that have the same length. Okay? There are a few ways that you can see this in a picture. First of all, they could be labeled at the same distance, like 5 inches, 5 inches. Then you know that they have the same length. Sometimes they won't have that, and there will just be two segments. You can never assume that two segments are congruent just by looking at them. Right now, yeah, those kind of look to be the same length, but there's a special symbol that would tell us they definitely are the same length if they don't have a measurement on them. And that symbol is the tick marks. Looks like a little line going through the segment. Those symbols indicate that those segments are congruent. So the symbol for congruent looks like this. It's like an equal symbol with a little squiggly above it. And also I would jot down that you want to look for the tick marks. That tells you that two segments are congruent. Probably already know what a midpoint is, and if you didn't already, from the front slide of this video made it pretty clear that a midpoint is a point that's halfway between two endpoints. So it essentially divides a segment into two congruent smaller segments. If it helps you remember, you can also put like the halfway point, halfway, right? It's right in the middle. A picture of a midpoint, well, first of all, a midpoint is just a point, but the way that you know for sure that a point is a midpoint, so I'm going to draw segment AB, and a midpoint would be located right in the middle. So if you have a picture that looks like this, again, you can never assume that point is a midpoint unless there is a symbol or a measurement to prove that it is a midpoint. So we're going to add our tick marks. That's very important. And again, I would record that you need the tick marks in order to have a midpoint. And you label it just like you would a point with a capital letter. I always choose M for midpoint. All right, let's try a few examples together. Let's say we have point B is a midpoint of segment AC. Okay, so I'm going to give you a diagram in a minute, but to finish our directions, find the value of X. So we want to first of all draw a diagram that's going to represent this. So I have segment AC. Doesn't not matter how big or small you make that segment, and B is a midpoint, so it's going to go right in the middle. I want to put my tick marks to indicate that it's definitely a midpoint. So the information given in this problem are going to be algebraic expressions for each of the small congruent segments AB and BC. So this is going to be 4x plus 2, and BC will be 8x minus 6. So now we need to figure out some type of an equation we can set up in order to find the value of x. Well, what do we know about these two smaller segments? Since B is a midpoint, we labeled these as congruent segments by using our tick marks, which means they must have the same length, which means that these expressions must be equal. So you're going to set up an equation by making the two congruent segments equivalent, and then we can solve for x. So I got that the value of x is equivalent to 2. Let's say you're a little unsure about that answer. You want to check it. How can we check it? We can simply take this value, plug it back into each of our expressions, and if we did it correctly, they should be equal since B is a midpoint. So I'm going to check AB, which was 4 times 2 plus 2, so that's 8. 8 plus 2 gives me 10. I'm going to check BC, which was 8 times 2 minus 6. 8 times 2 is 16, minus 6 is also 10, since these are the same. We did that correctly. All right, here's an example that does not give you a diagram. I'll give you a moment to go ahead and copy that down. Okay, so the first thing we want to do is draw our diagram. So A is a midpoint of segment CT. I'm going to draw my segment CT with A in the middle, put my little tick marks indicating that is definitely a midpoint. Then we want to label the expressions that have been given. So I've been given CA as 5x, and CT, that's the whole thing, is 7x plus 6. This is different than the last example we did. Last example, we had the two small congruent segments. Now we have one of the small congruent segments and the entire segment. So we want to think of what's the relationship between these two segments, CA and CT. There's a few ways you can describe it. Well, CA is half of CT, or you can explain this as CT is double the length of CA. Some people may also think of it this way. Well, if this is 5x and AT is congruent, that must be 5x. So that means the whole thing is also the same as 10x. However you want to think about this problem, it's going to result in the same equation. So I'm going to have the total 7x plus 6 that was given to me is 2 of the small congruent segments, 5x and 5x gives me 10x. And then we can solve for x from here. So I get, again, 2 is equal to x. I can go back and check it. If x is 2, this would be 10, and this would also be 10. And if I were to plug in my 2 here, I would get 14 plus 6, which is 20, which makes sense because 10 plus 10 should equal 20. Okay? Okay, so now we're going to go over the midpoint formula. Why would we use the midpoint formula, you ask? All the previous examples that we've done have just been on a plane, just a sheet of paper on a diagram. What if I gave you a coordinate plane question and I gave you 2 points that had coordinates? Then we are going to need to use the midpoint formula. So we're going to go ahead and draw our x and y coordinates and graph 5 units on each side using our ruler. Okay, so once we have our coordinate plane, we can add a scale to it, right? Each of these are going up by 1 or down by -1. And 2, 3, 4, 5. Perfect. So let's say that I gave you 2 coordinates. We'll start off with 1, 1, and 5, comma 1. If I asked you to find the midpoint of segment AB, you can probably do that just by looking at this segment and finding the halfway point, right? So halfway from A to B is going to be right here. We'll call this M at 3, comma 1. But we need to now figure out a strategy to actually find the exact coordinates of the location of our midpoint for any 2 points. All right, so what do we notice about the relationship between the midpoint coordinates and our endpoint coordinates? Well, we've got 1, 3, 5. Those are going up by 2. 1, 1, 1. Those are all the same. Let's try one more example to see if we can pick up on the pattern. So I'm going to start here at, we'll call this C, negative 5, comma 1. And then endpoint D, negative 1, comma 3. So I already graphed the midpoint of this segment. It's a little bit tricky to see this way. I'm going to call this X, negative 3, comma 2. Okay, so when you look at this example, you can start to see a relationship. Some of you might be thinking of rise over run or slope. Okay, from the point C to our midpoint X, this goes up by 1 and over by 2. Up by 1, over by 2. So it follows that same pattern. Okay, another way to describe the halfway point of something is by finding the average. So if you think of it that way, if I find the average of my endpoints, negative 5 plus negative 1, that gives me negative 6. If I cut that in half, it gives me negative 3. 1 and 3, that gives me 4. If I cut that in half, it gives me 2. Again, same type of pattern over here. If I add 1 and 5 together, it gives me 6. Cut it in half, it gives me 3. My endpoints for my y values, 1 and 1, that's 2. Cut that in half, gives me 1. So really our midpoint formula is just by taking the average of the endpoints. Okay, so it looks like this. Our midpoint is the average of the x values. So x1 plus x2 divided by 2. That would be the x value of our midpoint. And the y value of our midpoint would be the y's added together divided by 2. So whenever you're given 2 coordinates, just like we did in the distance formula, plug them right into this formula and you will have your midpoint. Here's an example that we can try by using the midpoint formula instead of graphing. Find the midpoint of A and B. If A is at 7, comma 3 and B is at 13, comma 4. So I'm going to go right to my midpoint formula. Just like we did on the distance formula, if you want to label x1, y1, x2, y2, that may be helpful. So I'm going to add my x's, add my y's, and simplify. 7 plus 13 is 20, cut that in half, 10. 7 divided by 2, you can leave it as 7 over 2, or you can put 3.5, 3.5, doesn't matter. Done. Go ahead and record down example number 2, work out your solution, and when you're finished, resume the video and see if you got the answer correct. Your final answer should come out to be a midpoint of -3, 1.5. If you didn't get this correct, take a look at the steps I did. Probably just got caught up on the negatives here. I hope this video helped you guys learn what a midpoint is and how to use the midpoint formula. Stay tuned for the next video, which is going to be finding a missing endpoint if the midpoint and one endpoint is given to you.